Hello my dear students, and welcome back to the chemical kinetics chapter. So students, in the previous class we studied about what is the meaning of order of the reaction. What is the meaning of order of a reaction, or what is the definition? It is a sum of power of concentration of reactants in the rate equation or rate law. Okay, then what is the significance of this order of the reaction? Order of the reaction tells us about how the rate of the reaction is affected by the change in the concentration of the reactants. Okay, then we had studied a different type of order of the reactions. Okay, what are those? Zero order, first order, second order, third order, and fractional order, and even we studied what is meant by pseudo first order reactions. Okay, these are the things that we had studied in the previous class. Okay, in today's class we shall study another concept called molecularity of the reaction. Okay, in the previous year, in the collision theory, in the states of matter chapter, there we have studied one concept called as collision theory. Okay, in collision theory you studied that whether in the liquid state or in the gaseous state, the molecules or the atoms or ions are always in a random motion. Okay, so in a reaction what will happen, if you want to get the product, then these reactant molecules which are moving in random directions, they must collide in order to give products. Okay, this is what we know from the collision theory, isn't it? Then what molecularity of a reaction tells us? See, molecularity of a reaction is number of reacting species. That reacting species may be a molecule or an atom or an ion. Okay, so the number of reacting species that must collide simultaneously. This is very important. What? The reacting species must collide simultaneously to give product. What is the meaning of simultaneously? Means at the same time these reacting species should collide. For example, see here, in this reaction two A molecules and one B molecule, when they combine you are getting a product, two C molecules and one D molecule. Okay, so as per the definition of molecularity, in order to get the products, what should happen? These three molecules must collide simultaneously. Simultaneously means all these three molecules should combine at the same time. Okay, as I have drawn in the picture here, it should be like this only. Two A molecules and one B molecules, they must collide simultaneously. Okay, then only we will get the product. It's not like that first these two A molecules will combine, then B molecule will come and collide with that. It should not happen like that. At the same time, two A molecules and one B molecule must collide, then only we will get the product. That is the meaning of molecularity. I hope you are understanding this. Okay, so the number of reacting species that must collide simultaneously to give you the product is called as molecularity of a reaction. So here how many reacting species are colliding simultaneously? 3. So what will be the molecularity of this reaction? It will be 3. Okay, so down again I have written another reaction. Okay, there I have written the molecularity is 12. The molecularity is 12. Why 12? Here 5 Br minus ions are there, then 1 BrO3 minus molecule or ion is there, and 6 H plus ions. So overall there are 12 reacting species are there, and these 12 particles must collide simultaneously to give this product. Okay, so now if I ask you, what will be the rate of this reaction? In other words, whether this reaction will be faster or slower. Just imagine this. See, in a reaction, if only two particles have to collide and give you the product, okay, then what will be the rate of the reaction? Fast or slow? It will be fast. Obviously you can imagine two particles can combine simultaneously to give product. That is quite easy. Okay, when it becomes to 3, okay, compared to two particles combining simultaneously. When it comes to three particles combining, okay, where is more possibility? Obviously the possibility in case of two. When more number of particles are increasing, means at the same time more particles have to combine simultaneously, then the possibility goes on decreasing. Then in a reaction where two molecules have to combine to give you product, that possibility is more, so the reaction will be more faster. So the reaction wherein three particles have to combine, the possibility is less, so compared to two molecules, this reaction will be slower. This is common sense what we can think of. So here now 12 particles have to combine together. If 12 molecules have to combine together, means what will be the rate of this reaction? Obviously the rate of the reaction will be slow, isn't it? This is theoretical assumption. Whatever we have discussed so far is a theoretical discussion. Means two particles can combine simultaneously, the possibility is more. Three particle means possibility is less. More than three means the possibility goes on decreasing. Okay, on that basis also scientists thought that even the speed of this reaction is less, but experimental data says that this reaction is faster. It is not slow, but this reaction is faster. Then when scientists studied in detail about such reaction wherein two or more than two particles have to collide simultaneously, some of the reactions obviously they were slower and some of the reactions were surprisingly faster. Then on analysis, on doing studies over those reactions, scientists found out that in such reaction where the molecularity is more than 3, okay, in such reactions what will happen? Such reactions will not take place in one step like here. In one step only the reaction is taking place, okay. But when the reacting species are more, then in such reactions the reaction will not take place in one step. Then the reaction will takes place through consequence of two or more steps. These reactions are called as complex reactions. Now simple, what is the meaning of complex reactions then? Complex reactions means the reaction wherein more than 3 reacting species must collide simultaneously. Such reaction will not take place in one step, but they will take place in 2 or more steps. Such reactions are called as complex reactions. I hope you are understanding, students. Okay, then the reactions which will contribute to the overall reaction are called as elementary reactions. Means see, if a reaction is taking place in 2 steps or 3 steps, then each step which is contributing to the overall reaction, that reaction is called as then each reaction, smallest reaction which will contribute to the overall reaction, such reactions are called as elementary reactions. See, then what is the meaning of mechanism, students? See, mechanism is a theoretical concept which explains the step-by-step changes taking place in a reaction. Remember this, in the beginning of this chapter I have said that what we will study in this chapter, we will study what is the meaning of rate of the reaction, what are the factors which will affect the rate of reaction, and also we will study mechanism of a reaction. What is the meaning of mechanism? Mechanism means, okay, it is a concept which will tell us the step-by-step changes taking place in a reaction. Okay, now you will understand what is the meaning of complex reaction, what is the meaning of elementary reactions and all. Let us take one example. Okay, here is one example I have taken. Okay, so in this nitrogen peroxide will combine with carbon monoxide to give you nitric oxide and carbon dioxide. Okay, now this here it involves 2 reacting species, but even though there are 2 reacting species, this is not a single step reaction, but it will take place in 2 steps. What are those 2 steps? Let us see. In the first step, 2 nitrogen peroxide molecules will collide and they will give you what? Nitric oxide and nitrogen trioxide. Okay, then what will happen? This nitrogen trioxide, whatever was produced in the first step, that will combine with carbon monoxide and we will get the product as nitrogen peroxide and carbon dioxide. Okay, now how to write the overall reaction? Then what you can do, see here NO3 is there this side and NO3 is there, this we can cancel out, isn't it? Then here on NO2 is there, here on NO2 is there, you can cancel. So overall reaction will come as NO2 plus carbon monoxide giving you one nitric oxide molecule and carbon dioxide. I hope you people understanding. So see, even though there are two reacting species have to collide, but the reaction is not taking place in one step, it is taking place in two steps. Okay, then this overall reaction, this is called as what? Complex reaction. Isn't it? Why? Because this reaction has taken place with the help of these two steps. After these two steps only we will get this. Okay, so this is called as complex reaction, and these two reaction which are contributing to the overall reaction, these two are called as elementary reactions. I hope you are understanding, students. Okay, then see here I have written here slow and fast. Okay, look here, I have written the rate for this reaction. What is the rate? Rate is, you can say, directly proportional to the square of the concentration of nitrogen peroxide. Why? If you look here, another step if I have to write, see, for this first step, if I write the R, okay, then it will come like K into NO2 into NO2. This overall becomes as K into NO2 square, isn't it? This rate almost same as the rate of the first reaction. Okay, so what I can say is, whenever it comes to complex reaction, remember this, students, or listen carefully what I am saying now. Whenever it comes to complex reaction, or whenever it comes to writing the rate of reaction for the complex reaction, the rate of the reaction depends upon the slowest elementary reaction. I'll repeat again, the rate of the complex reactions depends on the rate of the elementary reaction which is taking place very slowly. But it does not depend on the rate of the elementary reaction which takes place fast. Okay, now the question comes, why the rate of complex reaction depends on the elementary reaction which is taking place slowly. Now I will give you one analogy so that you can understand it. See, students, suppose one house has to be built and it is taking 1 year to build a house. Then most of the time is consumed for which? There are so many processes, like first we have to build the paya, then the pillar have to come, then the walls have to build, then the remaining work comes. What? This plumbing work will come, okay, electrical work will come, okay, then painting will come, then fitting the tiles will come. These are the things will come. But if you look into all these works, which has consumed more time? Obviously it has taken more time to build the paya, then to build the pillars, then to build the walls. These are taking the more time. Until and unless these three have built, you cannot do the plumbing work, you cannot do the electrical work, you cannot do the painting work, right? You cannot fit the tiles. So these things, rest of the things like painting, tiles fitting, electrician, plumbing, these are all can take place simultaneously. Within 2 months all of these work can be done, but most of the time is consumed for building the paya and pillars, isn't it? So we can say that most of the time in building the house was consumed for that. Why? Because that is the main thing. If that main thing is not there, rest of the other things cannot be done. Okay, in the same way, in a chemical reaction, the majority of the changes are happening in the slowest step only. In the fastest step, only minor changes will happen. Therefore, we will not consider the minor changes that are occurring in the reaction. We will consider the elementary reaction where the majority of the changes are taking place. Therefore, we will consider, remember this, in a competitive examination, it is asked that in a complex reaction, rate of the reaction depends on what? It is the slowest elementary reaction. Remember this. Don't forget, remember this. Okay, we shall take another 2 or 3 examples, then you will get a clear idea regarding this. So students, now as we know what is meant by molecularity of a reaction, in theory as well as in competitive examinations, they will be asking, they will give one reaction and they will ask you what is the molecularity of the reaction. Okay, so here see, only one molecule is involved. Hydrogen peroxide is decomposing to give you water and half mole of water. So what is the molecularity? It is only one, so it is called as unimolecular reaction, or molecularity is how much? 1. In the second example, you can see nitric oxide is reacting with ozone to give you nitrogen peroxide and oxygen. So there are 2 reactants are involved, so it is called as bimolecular. And in the next one, you can see there are 2 nitrogen peroxide and 1 oxygen is involved, so it is called as trimolecular reaction. So whenever they ask you what is the molecularity of a reaction, you must be able to answer it. Means you have to count how many number of reacting molecules are colliding to give you the product, and that will be your molecularity of a reaction. Okay, now here is another example. You can understand it here. Here what we can understand is 2 molecules of nitrogen pentoxide are decomposing to give you 4 moles of nitrogen peroxide and 1 mole of, or 1 molecule of oxygen. Okay, so it is also a complex reaction and it is also taking place in 2 steps. First one is here in the first step, 1 molecule of nitrogen pentoxide will decompose giving you nitrogen peroxide and nitrogen trioxide, which is the slowest step. Next, in the step 2, again another nitrogen pentoxide will collide with nitrogen trioxide, which will give you 3 molecules of nitrogen peroxide and 1 molecule of oxygen. Then overall reaction is like here NO3, here this side NO3 get cancels, so overall reaction is this. We are getting the overall reaction. Now if they ask you what will be the rate of the reaction, then you must remember what? The rate of the complex reaction depends on the rate of the slowest step in the reaction. Okay, so for this, how you write the rate? So I'll write the rate it as rate is equal to K into N2O5. This is the rate for this reaction, isn't it? So this is the rate for the overall reaction. So the same way I have written here. So sometimes they will ask you what is the order of the reaction or what is the molecularity of the reaction. Here it is bimolecular. Molecularity will become bi, because 2 molecules of nitrogen pentoxide are colliding and giving you this 4NO2 and O2. This is a bimolecularity, but the order of the reaction is 1. Okay, I hope this concept is clear. Okay, now for in a theory part or in a board examination point of view, sometimes for 2 marks they will be asking you write any 2 differences for molecularity and order. Okay, I have listed some of the differences between them. Okay, first thing is always remember to write the definitions. Here I have not gone into the details of writing the definition, as you already know it. Okay, then see, molecularity is always a whole number. I hope you can understand. 1, 2, 3 like this. It cannot be like 1.2, 1.3 or 2.2 like this. It cannot be in fractional. Okay, molecularity will be always a whole number. Whereas order, it can be a whole number or it can be fractional. We have know that fractional order reactions are also there. Okay, so order can be a whole number and also it can be fractional, but whereas molecularity will always be a whole number. Then molecularity cannot be 0, isn't it? In a reaction, if no reactants are there, how a reaction will it cannot occur, isn't it? Therefore molecularity cannot be 0, but order of the reaction can be 0. Okay, then molecularity is not applicable to complex reaction, but for elementary reactions only it is applicable, whereas the order of a reaction is applicable to both elementary as well as complex reactions. So these are the 4 differences I have listed here. So easy, which are the easy for you can remember, but at least I know that you will be remembering the definitions. So first write that, then anything you can from these you can write it. Now we shall solve some of the numericals based on order of the reaction. and then we will get more clarity about what is the order of a reaction, how does it affect the rate of a reaction and all. Okay, now we shall solve some numericals. Yeah, students, now we will solve some numericals. Okay, so the first numerical is here, that calculate the overall order of the reaction. Okay, there are two reactions they have given and they want you to calculate what? Order of the reaction. Now you already know in the previous class how do we calculate the order of the reaction. For this reaction, order is represented by small n. This is equal to what? The sum of the powers of the concentration of reactant terms in the rate equation. So what are the powers now? So half plus 3 by 2, so this will be 4 by 2, so this is equal to 2, so n is equal to 2. So what is the order of the reaction? It is a second order reaction. Now here again, order n is equal to the sum of the powers of the concentration terms, so it will be what? 3 by 2 plus minus 1, so this 3 by 2 means 1.5 I can write 1.5, then plus into minus it will be minus 1, so 1.5 minus 1 it will be half, so n is equal to half, so it is a half order reaction. I hope this point is clear. Okay, then second one, it is saying that identify the order of the reaction from the following rate constant. Yesterday we have discussed how to calculate the unit of rate constant. Haven't we discussed about it? Yes. So here what they have given is, they have given you the rate constant. They have given the rate constant for a reaction, and from the rate constant we have to understand which order reaction is this. So to understand, first look into the units here. From the unit itself you can calculate what? The order of the reaction. Yesterday what was the shortcut that I had discussed? The shortcut is K is equal to moles per liter, power is 1 minus 1 per second. Okay, now to get this unit, put the order of n here. What will you get? If you suppose n is equal to 1, suppose you put n is equal to 1, then what will you get? 1 minus 1, 0, so this term becomes 0, so only per second will remain. Okay, so if the order of the reaction is 1, what is the unit of the rate constant? It is per second. So here see, already in the second problem what we can say, the unit of the rate constant is per second. So this is which order? This is first order. Clear, student? Okay, then again to get again after putting n is equal to 1, okay, put here n is equal to 2, what you will get? So 1 minus 2 is minus 1, so mole to the power minus 1, so liter, already minus 1 is there, minus 1 into minus 1, what you will get? Plus 1, so this will become liters per mole, liters and per second. So this is the same unit what we are expecting. So this is second order reaction. So this is second order and this is first order reactions. Okay, first you can start with n is equal to 0 itself, 0 order reaction, n is equal to 0. So if you can get any of these units here, you will not get it. So then put n is equal to 1, then n is equal to 2, like this you have to try. But you have to remember this shortcut. Okay, then only your numerical solving problems will be better. Now we will come to the main. That is, yesterday we had, in the previous class we had discussed about how the order of the reaction affects the rate of a reaction, isn't it? So now, here let us understand what is in the numerical. Okay, see, what they have given is the rate law or the rate equation for a reaction involving A, B, C has been found to be. So rate of the reaction involving ABC is found to be like this. Okay, here it is C square. Okay, then calculate what happens to the rate equation or what happens to the rate of the reaction. Okay, so in the first problem what they are saying you, that if the concentration of A is doubled, what happens? For the first I will answers or solution. Okay, so first you write down the rate equation. It is saying A into B into C square. What they are saying? That the concentration of A is doubled. When concentration of A is doubled, then R is equal to K into 2 into A. This will become like this. This will become like this. So overall what I can write? 2 into K into A, B into C. So what is happening to the rate of the reaction? It is becoming double. When you increase the concentration of A to double, you have made the concentration of A is doubled, so rate of the reaction is also doubled. Here I can write, therefore rate also doubled. Okay, rate also doubled. Now the second problem, what it is saying to you? Okay, if the concentration of C is doubled, again first write the equation properly. A into B into C square. Okay, now when concentration of C is doubled, then what happens? So what you can write? K into A, B. Now concentration is C is doubled, 2 into C square. So what it will become? So 4, or I can write K into A, B concentration, then 4C, or in simple I can write it as 4 times. Okay, therefore rate increases by 4 times. I hope you people are understanding it. When the concentration of C is doubled, what we have to write? Here we have to write 2C. Okay, why? Because the concentration is doubled. So on simplifying, you will get that the rate is increased. R is equal to, this is what we are getting. So rate of the reaction is increased by 4 times. Okay, next the third one, what they are saying? Yeah, here this we solved, this we solved. Now if the concentration of B is half or halved, means what will happen? When B is equal to half, then I am solving it directly here. Okay, so R is equal to K into B by 2 it is. So overall I can write it as 1 by 2 into rate constant into this. Isn't it? So what I can say? Rate is, therefore rate also gets half. Rate also gets half, because see with respect to the concentration, here in the rate equation you can see the rate of the reaction with respect to B is what? Power is 1. So first order reaction with respect to the concentration of B, rate is order is 1. So if it is doubled, it also gets doubled. If it is half, it also gets half. Same in the case of A, it is also first order reaction. If the concentration of A is doubled, then rate also gets doubled. If its concentration is halved, then rate of the reaction also becomes half. In the second case, as we have seen here, the power is 2, or the exponent is 2. So if the concentration of this reaction is doubled, then the rate becomes 4 times. So if the reaction is half, this becomes half, means half of the double, it becomes unimolecular. I mean it remains the same. Okay, there is no change in that. Okay, so last one, that is fourth one. What they are saying? That yeah, where it is? Yeah, here. If the concentration of all A, B, C are tripled, then when A, B and C are tripled, then what will happen to the rate equation? R is equal to, small k into tripled means 3a it will become 3b, then it will become as 3c whole square. This will become 3c whole square. So on solving this, what you will get? I'll write it in simple for you people. 3a into 3b into, what is the square of 3? It is 9. 9c it will become. Now if you multiply, what you will get? R is equal to, now 3 3s are 9. Again 9 into 9 is 81k. This is the rate. So what you can say? Rate increases by 81 times. Rate increases by 81 times. I hope you people understanding, because in competitive examination or in board examination, the tricky question will be on order of the reactions only. Okay, they'll ask you when the concentration is doubled, or it is made 2 times, or it is made half or tripled, what happens to the rate? Okay, these are the type of questions they will be asking. And rate constant, based on earlier whatever questions we have solved, based on that also questions will be coming. So if you are perfect in the numericals, then rest of the things, if you practice more numericals, I know the mentality of the student is that they don't want to do the numericals, they just want to be perfect in theory part. Okay, at the end of the day, that when we discuss the question or the chapter, we will be focusing more on the theory concept. But student, remember this: if you want to do well in your competitive examination, means if you are the aspirant for NEET and IIT, then more numericals if you practice, then your theory part you can understand it better. This is my personal experience, I'm telling you. If you are perfect in solving numericals, then the meaning is that you are perfect in your theory part. And also I prefer, or I want you to solve as many numericals as possible. Why? See, what happens is in competitive examinations, what happens? Simple problems like this, they will be carrying maximum marks. Okay, simple, they will be simple. You have to just substitute some values and you should know how to do the calculation of larger number or a division of smaller number, or how to make it addition and subtraction. These are the basic mathematical functions. If you know properly, then solving numericals is not a problem. But what our students will do, they will always choose for a theory. In theory, what will happen? They will give so many options that you will always get confused. Okay, but in case of numericals, simple calculations will be there, simple mathematics will be there, because in competitive examinations no calcs is allowed. So the questions, no matter what numericals you have to solve, but they will be simple numericals will be there. And if you solve numericals, big marks you can score. Like this question only if appears and 4 marks it is giving, why to lose 4 marks? Simple calculations are there. Whereas in theory you have to attempt 4 questions, and again in all the 4 you may get right or you may got wrong there. So attempt as many possible numericals. It's better, always better. Okay, so in the next class we will continue with the other concepts, and let us see how the concentration will affect the rate of the reactions. Okay, thank you students.